All right, here we go. 8.2, trigonometric polar form and complex numbers. Okay, so this is what we're going to be doing. Here we go. So when we're talking about, let me hide this for you. Their definitions if you want to, yeah. So horizontal axis. So when we refer to it as a horizontal axis, we call that our real axis. Okay, so our horizontal axis is our real axis. Our vertical axis is going to be our imaginary axis. Okay, horizontal is our what? And our vertical is our imaginary. Okay, so when you have a complex number, if you remember from college algebra, a complex number means that you have a real plus a or minus an imaginary. Do y'all remember that from algebra 1? Now college algebra. Okay, and how do you graph it? Well, you graph it using this concept. So your real is your x. So notice here, if I have 2 minus 3i, I'm going to go 2 on the real, and then I'm going to go down to 3 on the imaginary, and that's the vector. Yes? Easy enough so far? All right. Now, the sum of two complex numbers is represented by the vector that is the result of the vectors corresponding to the two numbers. So basically, when you're adding the two numbers, you're going to add your reals and your imaginaries. Got it? So you add the reals and the imaginaries, and that creates the sum of the two vectors. So I means imaginary. Okay. So, for example, if I have 4 plus I, so 4 plus I is graph, boom. Then I have 1 plus 3i, I graph 1 plus 3i, boom. And their combined solution is going to be 5 plus 4i. Okay. When you are adding, it ends up creating the diagonal of a parallelogram. Do you see that? It creates the diagonal of a parallelogram. Easy enough so far? All right. So here we go. Let's do an example. We have 6 minus 2i and negative 4 minus 3i. And we want to find the sum. So you're going to add, right? So you're adding your real to your real, your imaginary to your imaginary. Real to real, imaginary to imaginary. What's 6 plus negative 4 and negative 2i plus negative 3i? Okay. And we end up with 2 minus 5i. Yes? Okay. Now, if it asks you to choose the graph or to graph, remember, your horizontal axis is your real values. Your vertical axes are your imaginary. Okay. So when we graph our 6, I'm going to go over to 6 on the real and down 2 on the imaginary. When we graph the negative 4 minus 3i, I'm going to go over negative 4 on the real and down to negative 3 on the imaginary. And their sum is going to always be the diagonal of a parallelogram. Ta-da! Still with me? All right. This is where the trick comes in. Okay. So moving on, we're good at the base. Moving to first base. Moving off home plate. Okay. Now, we talked about your X and Y coordinates are based off of your sine and cosine of theta, right? So we've learned, this is stuff we've already learned, correct? The relationship between X, Y, R, and theta. Nothing is new. We learned that X equals your radius times the cosine of your theta. Your Y equals your R times your sine of theta. To find your R, it's the square root of X squared plus Y squared. And that's because X squared plus Y squared equals R squared, right? And if I need to get R by itself, I have to take the square root. So what's the bottom thing? No, we haven't gotten there. I'm just making sure we understand the stuff we already know. So this is all of our real information from trig, correct? Okay, now how does it apply in terms of complex numbers? Okay, when we're looking at the complex number, remember your X, that is your real. In this turn, your Y is now your what? imaginary. And I always spell imaginary wrong. Just go with it.
Our Y's are imaginary?
Mm-hmm. Because your vertical is your imaginary. Yes? Remember? Horizontal, real?
Yeah.
Okay. So when we look at it and we're graphing and analyzing, my radius is going to come off based off of what my X and my Y are. So let's dive in. When we're looking for the trigonometric form or polar form of a complex number, this is what we're coming out to be. So X plus YI is your radius times cosine theta plus I sine theta. That is going to be the polar form of it. With the trig polar form.
So R cosine theta plus net.
Yes.
That's X plus theta.
Yes, that's your imaginary for your trig values. So A plus BI is normal numbers, right? No trig involved.
Right.
When we're involving trig, this is the format that it comes out to be.
Oh, so it's literally the same thing.
Yes, because it comes X plus YI, right? And X is what again? X is our cosine. X is cosine. Y is our sine. And X is our real. And Y is our imaginary, right? Okay. Now, mathematicians are lazy. So sometimes, or they may refer to this, the inside, as cis theta. Why? Because they're lazy. They got tired of writing that.
Or is that like we put that like
No, it's just when you're writing it in your notes, they got tired of writing it repeatedly. So they made the abbreviation of cis theta. Is it necessary? No, but I just want to make sure you're aware of it and you've seen it. Okay, so when you see that notation, it just means that you have R cis theta, which means that I have R times cosine theta plus I sine theta. All right, did we all write down the form? I'm fine with the long form. It doesn't bother me that much. I'm not this kind of lazy. So. All right, R is going to always be positive because R is what again? Your distance, right? Your radius is your distance from the origin. So that's why it's reminding that it's the absolute value because your R is always going to be positive. All right, let's do an example. So up first, we're going to convert from trig form from trig form to regular form. So polar to regular, rectangular form. So we have 2 cosine 300 plus I sine 300. Your A plus BI without trig. Without the trig. Mm-hmm. So we're going to pull out what we know. We know that cosine 300 equals 1/2 from our unit circle, correct? The sine of 300 is negative square root of 3 over 2. Information we already know, correct? Anyone's like, I do not. Got it? All right, we're going to substitute those values in. We find, then we substitute.
So the angle will always be in the unit circle. It won't be like a random number.
Unless, if so, then it's a calculator problem. Now we're going to distribute our radius. It's combined. It goes to each one. So we distribute our radius. So 2 times 1/2 is 1. 2 times another half is 1. 2 times 1/2.
Oh.
2 divided by 2 is 1. 2 divided by 2 is 1. And that's your rectangular form. And you can double check yourself if you're unsure. You're like, I don't think I did this right. Guess what you can do? Plug it in and check. And what do you notice? Do I get the same answer? Yes. All right. So how did we feel about going from trig to rectangular form? Good? All right.
Will we ever have to find like the code for this?
No, it's not part of the,
Oh, okay.
all right, now we're gonna go to graphing. Or looking from a graph. So we're gonna go the other way. So we just went from trig to rectangular. Now we're going rectangular to trig. So we're going backwards. So we're gonna be given here and we gotta end here. Got it? All right. So the first thing we're gonna do is sketch the graph. Why? It's just better to have a visual of it, know where it falls, what quadrant you're gonna be in, right? Because our quadrant dictates our possible values, right? Okay, so we're gonna graph x plus yi first. So we graph in the complex. Remember, when you're graphing, your x is your real, your y is your imaginary. After that, then we're gonna use r equals the square root of x squared plus y squared to find our radius. And then we're gonna find our theta. To find your theta, remember theta equals y divided by x. And based on where we graph, we'll know whether theta is positive or negative, and whether the x or the y. All right, 3 easy steps, right? How you feel? Doable? Okay. All right. So be careful to choose the correct quadrant. So where it lies is important. Got it? All right. Up first. So we have negative square root of 3 plus I in trigonometric form. So what's my real? Negative square root of 3, which makes that my x value, right? And my imaginary is 1i. So y equals what? Y is just 1. Okay, your y is just 1. So when I graph it, I have to be negative square root of 3, which puts me in quadrant 2. And my 1 is positive, so it's going to put me in quadrant 2 instead of quadrant 3. Because your y is also.
Do we always have to graph it?
I think for me, it helps me not make mistakes. The visuals there, I now see everything back in normal terms, right? This takes us back to chapter 2. Finding R.
But why is it in quadrant 2?
It's quadrant 2 because your x is negative and your y is positive, which puts me in quadrant 2.
I thought it was going on like the plus minus.
It's based off of what your values are. Remember, it's x plus yi. And so then to find r equals 2, we had to use Pythagorean theorem, right? So we're doing r equals the square root of negative square root of 3 squared plus 1 squared, which is the square root of 4. And the square root of 4 is 2. So what angle am I describing? That has these values. To do that, we're going to look at the tangent. So our tan theta, I thought I wrote it. So what's tan? Tan is y over x. What's our y? Oh, yes. I didn't. Did you say that?
No.
Oh, I was like, did you say that? Did I misunderstand it? So our tangent is y over x, which is 1 over the negative square root of 3, which equals negative square root of 3 over 3. Which is why theta equals what? 5 pi over 6. Theta, tan theta equals that, but what is theta? What theta value gives me this? And the answer is, you go back to your unit circle. On your unit circle, if you go to your unit circle, when do you have your x value as negative square root 3 over 2. It was undoing that, right? And your y value is 1/2. And where is that at? At 5 pi over 6.
We can't, okay, so do we have to find theta? Cause like,
Yeah, you need to find your theta.
cause like, look, well,
You're-
now we just-
Yeah.
Always look here.
That's what I said. Using your unit circle.
So,
Using your unit circle, what is your theta that satisfies this problem? And that gives us a reference angle of pi over 6, which means that 5 pi over 6. You remember how I told you all I know was quadrant 1 by heart real fast? That's because if I know pi over 6 is that's its tangent value, but it's negative, so that puts me in quadrant 1 or it puts me in quadrant 4. It helps me using reference angles. But either way, our theta is 5 pi over 6. And now that we know our theta, okay, pause.
no.
So here's our theta, and our goal now is to write this in what form? Trigonometric form. In trigonometric form, it's going to be r times the cosine of your theta plus sine I of your sine theta, right? Do we now have our theta? So it's going to be cosine of 5 pi over 6 plus I sine of 5 pi over 6. Our theta, that's our tangent value. This is our tangent value. Your theta is your angle. The tangent of the angle is this. Your theta at that angle. The tangent was to help you figure out, without looking at your unit circle, what value you're looking at. Yeah. What angle are you at? Okay. So now I'm going to plug in everything that we have. What is our R? 2. What is our theta? 5 pi over 6, right? So I plug that in and then I simplify. Okay. And this is what it means when it says you can write it as a shorthand response. So we went from rectangular to trig. Talk to me.
It's fine, the tangent really makes me feel like.
The tangent is just a tool to help you find your theta.
Are we gonna have our unit circle for the thing?
For the test? I don't care. All right, let's try again. Ready to do that again? So now we have negative 3i. So this time, what is our x? X is 0. What is our y? Negative 3. Make sense? Okay, so when I draw it, why is it all coming at once? So when I draw it, I'm going to go to 0. Then I go to negative 3, which puts me on the what axis? On the y-axis. And what's the degree at this angle? 270. Do we see that? That's fine. Okay, so x equals 0, y equals negative 3. So when I create my graph, I go to 0 for the real, right? And I'm going to go down to negative 3 on the imaginary, correct? Okay. And so what is theta right here? 270, right? So we have our theta. And logically, your radius is your distance from the origin. What is our distance from the origin? 3. So we have our r, we have our theta. Can I write my form? Yes, because all I need is r, parentheses, cosine theta, plus I sine theta. Or you have your r cis theta. which stands for cosine imaginary sine. Okay.
How do we get the radius again?
Your radius stands for your distance from your origin. So either using logic, or you can do x equals the square root of x squared plus y squared, which would be 0 squared plus 9, which is 3. Right? Okay, I have everything I need to plug in. So I plug those values in. Why is it tripping? And we get theta is 270. We plug it in, and there's our trig form. Yay?
Why is it negative?
Because it said to give it the degree measure.
You talking to me?
Oh, because why is it negative? Because your sign is negative. Y is negative.
Oh.
It was negative, right? So whether it's minus or plus dictates whether your sign is negative or positive. And in this case, our sign is what? Negative. Yeah?
We about to leave?
Mhm.
We about to leave?
No, Laura, it's weekend.
I am. Oh, pretty nice.
All right.
Hold on.
Oh, why didn't you say hold on? My bad.
Where? I think I got it.
Okay.
Oh my gosh, radius, be quiet. Not you. I'm talking about station. Radius of the building. You are right next to my ear. Hypotenuse, right? Okay.
Your radius? Yes. If you think about it, yeah. Because it's Pythagorean theorem. X squared plus y squared equals c squared.
She don't have to do that.
Okay. America, you have any questions, or you feel okay about it? Okay.
So.
Yeah,
So
okay.
will you be able to like record like something?
Are you gonna ask me now?
No, it's the audio. Is this like the last one?
You can just do.
Yeah, the last one is just talking about calculator. So notice that we have 120. I just want to go really quick. So on this one, we have 125, and is 125 on our unit circle? No. So we would have to use the calculator to approximate. Does that make sense? So we would use the calculator to find the cosine of 125, the sine of 125. So in the calculator, I get these values in degree mode because it's degree. So in the calculator, I put it in, and I'm going to get the approximate values. And then all I'm going to do is simplify it down to whatever it tells me to round to. So this is when you're not on the unit circle.
And then we distribute, right?
And then you distribute
So where's I? Oh,
at the end. So we distribute the 6, right? And then those are our simplified answers. Yes?
Close to 125, you get that little decimal.
Yes.
Times that and that.
All right. The last part was just making sure that's if the value is not on the unit circle, you have no choice but to use the calculator to approximate.
What are we gonna have to use the calculator when it's in rectangle? Is that?
So yes. So glad you asked. So go ahead the other way. If I have 5 minus 4i, we're gonna identify where it lies. So we know that my x is positive, my y is negative, so it has to be in quadrant 4. Make sense? So my angle is in quadrant 4. And when I get here, notice that my radius would be the square root of 41. Is that an easy radius? No, it is not. So got our square root, then our tangent. Well, this isn't going to be easy. So to find your theta, we have to use inverse tangent, which means that we have to use the.
Wait, we use this for y? See, I think we're going too fast, and I'm being. Why are we going over this tomorrow?
I won't see you tomorrow, which is why I need to finish the video. And so,
Oh, are you gonna post it today?
yes. So just really quick though, while you're in my face, just want to make sure you're good. So you have tan theta equals negative 4 over 5, right? Because theta is y over x. And we know that our x is 5 and our y is negative 4. The y is just the 4. Yes? So to find our theta is going to equal tan inverse of negative 4/5. And that's what we're putting in the calculator. Because you have to find your theta. It's not on our unit circle. So when we put it in the calculator, we're going to get an approximate value of negative 38.6. What that's telling us is how far we are from here, correct? Does that make sense? That's your 38.6. So if I'm 38.6 degrees away from 360, what is my theta? 321. Does that make sense? All you're doing is 360 minus that. So now you have your theta. So your theta is 321. You have your radius, you have your theta. So can you write your form? Your trig-
What do we have to write in like radian?
Then you would do the same thing. Make sure your calculator's in radian mode
Oh.
and subtract from 2 pi instead of 360.
Okay.
And so then your answer would be square root of 41 cis 321.34. All right, and that's it.
So you just record it, email it back to me. This question,
What?
those questions got sent to you.